Hello and welcome back. Today we'll cover how to solve systems of linear equations and how to solve them with substitution. So, quick review of vocabulary. A set of two or more equations using the same variables is called a system of linear equations. The system of all ordered coordinates that simultaneously make all equations in the system true are called a solution of a system of linear equations. Okay, when we decide to use substitution, there are definitely several methods, and we definitely want to pick a method that works best for that problem. But today we'll practice substitution, and there is a system and method for solving them. The first is you want to isolate a variable. So solve for one of the variables in one of the equations. Then you want to substitute, and then we're going to solve the equation for that variable, and then substitute again, bringing that value back into the equation to solve for the second variable. Remember, we're going to have two variables here in the linear system. Okay, the last one is to check your solution, and that's by plugging in the values to verify that it's true, and sketching a graph if you'd like. Okay, let's go to the first example. So we want to find the solution of this system of linear equations, and we can see pretty clearly that on the second equation, you already have the variable isolated. So it's easier to use that equation since we already know that y equals 3 plus x. Now for the second step, we're going to plug that value in to the second equation. So remember, it was x plus y equals 5. And we're going to put this whole expression in for y. So that'll equal x plus 3 plus x equals 5. So now we are using both of those equations, and we substituted the y value in the first equation. Now we're going to solve for that equation. So meaning we're going to say, what does x equal? Well, we can combine like terms. So we get 2x plus 3 equals 5. And notice I'm going down, okay, to show my work, and the equal sign, I'll fix this one so it looks a little bit better, but it should be pretty balanced, like so you could see that equal sign is also going down, okay? All right, so let's solve for this one. So to get the x by itself, we're going to have to subtract 3 from both sides. So we get 2x equals 2, and we could divide both sides by 2, so x equals 1. Now we have the value x equals 1, and we're going to plug that value back in to the first equation here to figure out what y equals. So since y was 3 plus x, and we know that now x is 1, well, we can say that y equals 4. Okay, and so to check our equation, well, we've been using y equals 3 plus x. So to check our equation, we're going to use the first equation, which is x plus y equals 5. So let's put this equation in here, x plus y equals 5. And I'm going to plug in the values that I got for steps 3 and step 4. So x equals 1 plus 4, and that does indeed equal 5. So when we write the solution, remember, we're going to write the solution as an ordered pair. We know that x equals 1, y equals 4. So the solution is going to be 1, 4. Let's go to another example. For this one, we have 3y plus x equals 7 and 4x minus 2y equals 0. You notice that none of the variables are isolated. So when we want to isolate a variable, we want to decide and see which variable has a coefficient of 1. So it's really this variable that we can easily get by itself, right? Because if 3y plus x equals 7, well, I can subtract 3y from both sides, and then I'll get x equals 7 minus 3y. So now I have that variable isolated, and I can plug this value in for the x in the second equation. So we know that 4x minus 2y equals 0. And I'm going to plug in the x, right? So I'm going to replace the x with the 7 minus 3y. And then just continue on, minus 2y equals 0. Okay, so here we substituted in for x. The next step is to solve this equation for that variable. So we're going to have to distribute the 4. So 4 times 7 is 28. 4 times negative 3y is negative 12y. You can combine like terms. So this is minus 14y. We can subtract 28 from both sides, so that's negative 28. And then when we divide by negative 14, y equals negative 2. Now we know that y equals negative 2, but we still need to make sure we find what x is. So remember, we have to plug it into this equation up here, right? Or it's the x equals 7 minus 3y. And so this is going to be 7 minus 3 times, this was positive 2. So x equals 7 minus 6. So x equals 1. Okay, so here you kind of see y equals 2. I'm going to just put a box around so you can see clearly. And x equals 1. Now we want to make sure we check our equation. So we have to make sure we plug those values back in to the second equation. So remember, the second equation, just move up here, was 4x minus 2y equals 0. So I'm going to plug in x equals 1. So 4 times 1. And then 2 times our y was 2. And 4 minus 4 does equal 0. Check. Okay, so to write our answer, the x was 1, the y was 2. So we're going to write our final answer as 1, 2. Let's go to the next example. Okay, so for this system, we do have x already isolated here. So x equals 3 minus y. So we don't have to do anything after that, right? So that's already isolated. And now we're going to plug that into the equation, substitute. So the second equation was x plus y equals 7. And we're going to put 3 minus y in place of x. So plus y equals 7. And now we're going to solve this equation. So 3 minus y equals, well, if we look at this, these two terms are going to cancel each other out. And so we're going to get something that says 3 equals 7. Now that's tricky because 3 does not equal 7. So what this means is that these two lines will never intersect. There's not going to be a solution. So we can actually say right here, there's going to be no solution. And oftentimes you'll see the symbol like a 0 crossed out. Okay, so this answer is actually no solution. Okay, and you can write that on words. So I'm just going to check that just to show you how to see that visually. So we knew that this was x equals 3 minus y, right? So if I was going to graph that, I could say, well, that's equal to, let me just rewrite it. I'm going to write it in slope-intercept form. Okay, so that's minus y. So when I add the y here and I subtract the x, that equation can be rewritten as y equals negative x plus 3. The second equation was x plus y equals 7, and that can be rewritten as y equals negative x plus 7. So on a graph, I'm just going to use a space. So on a graph, the first line would be 7 here, would be the y-intercept and go down. And then the y equals negative x plus 3 would be right here. So they're going to be parallel lines. So parallel lines will never intersect and will not have a solution. Okay, let's go to the next example. So for this one, we can see the variable is not isolated. Okay, so we need to make sure that we go and isolate one of the variables. So you have to decide which variable to isolate, and we want to look for the equation where the variable has a coefficient of 1. So we're going to use that first equation, and we're going to isolate y. So 2x plus y equals 4. Subtract 2 from both sides, so y equals negative 2x plus 4. Okay, now we're going to substitute that into the other equation, which is 4x plus 2y equals 8. So wherever we see the y, we're going to replace the y with negative 2x plus 4, and then solve for x. Okay, so from here, let's make sure that we distribute. So 4x minus 4x plus 8 equals 8. You can see the x's go away, and so we get 8 equals 8. Now, this is true. So if this is true, that means that we're talking about the same line. So the solution is going to be all real numbers, because any number that you plug in will be the same y. And we use that symbol that kind of looks like a paragraph symbol with an R. Okay, so all real numbers. So just to verify, I'm just going to isolate the y for the second equation, just to show you. So this was the equation when I isolated y for the first equation. Now if I isolate y for the second equation, which is, and we're not substituting anymore because there's no solution. All real numbers is the solution. So the equation is 4x minus 2y equals 8. When I subtract 4x and then divide by 2, you will notice that we get the same exact line. So the equations up here are two different ways to write the equation for the same line. So since these are the same line, it means that all the numbers will work. So we can say all real numbers for your solution. So remember, when the solution is false, like this one, 3 does not equal 7, that will be no solution. And when the solution is true, the solution will be all real numbers. Okay? All right, now example 5 has a word problem. So for a local fair, there's an admission fee, and it's $1.50 for children and $4 for adults. On a certain day, there are 2,200 people that enter the fair, and $5,050 is collected. So now we're going to have to write our system of equations to figure out how many children and adults attended the fair. Before you get too far along on a problem like this, make sure that you identify the variables. We're going to use x to represent the number of children and y to represent the number of adults. When I write my first equation, that's going to be the number of people in the fair. So x number of children plus y number of adults would equal 2,200 total people. Our second equation is going to be about the money. So if we had 2 children attend the fair, they'd pay $1.50 each, or $3. It'd be 150 times 2. So we're always going to multiply the ticket price by the number of people. Okay, so it'll be $1.50 times the number of children, and then $4 for each adult. And it's a total of $5,050 collected. Okay, setting up those equations is probably the toughest part. Now let's go to substitution. There is one equation, the first one, that already has 2 variables with a coefficient of 1. So you can choose whichever variable to isolate. Here I'm going to isolate x and subtract y from both sides. So x equals negative y plus 2,200. Now I'm going to have to substitute that into the second equation. So we have 1.5, and instead of x, I'm going to plug in negative y plus 2,200 plus 4y equals 5,050. Okay, so when we want to solve this equation for step 3, we're going to have to distribute. So we'll get negative 1.5y plus 2,200, which is 3,300, plus 4y equals 5,050. And I'm going to solve for y, so let's combine like terms. Put those two together, we get 2.5y. And we can subtract 3,300 from both sides. So 2.5y would equal 1,750. And if I divide both sides by 2.5, y equals 700. Now that means that there were 700 adults that were at the fair. For the fourth step, I have to plug it back into the equation. So we know that x equals negative y plus 2,200. So x is going to equal negative 700 plus 2,200. So when we subtract 700 from 2,200, we'll get 1,500. So there must have been 1,500 children and 700 adults. To check our answer, we're going to plug it back into that original x plus y equals 2,200. You can try plug it into both, right? But I'm going to plug into this one. So we have 1,500 plus 700 does equal 2,200. And just because we want to make sure it works, you can also plug it into the other one. 1.5 times 1,500 plus 4 times 700. We want to make sure that equals 5,050. All right, so 1.5 times 1,500 is 2,250. And then this is 2,800. And when we add them together, it does indeed equal $5,050. All right, let's get to our next word problem. Here we have an exam that has 145 points and contains 50 questions. Some questions are 2 points. Some questions are worth 5 points. We want to figure out how many 2-point questions and how many 5-point questions are on the test. So remember, the first thing is to identify your variables. We'll say x is the 2-point questions. And I would put the number of 2-point questions. And then y will be the number of 5-point questions. And I'll just put a Q there for questions. Okay, so how many total questions are there? the total amount, or the number of questions, was 50. So x plus y equals 50. Now the second equation is the value, or last time we talked about the money, but now we're talking about the value. So 2 points for each of those questions, so 2 times x, plus 5 points for each of those second type of questions, so 5 times y, will equal a total of 145 points. Now let's isolate a variable. Okay, so from here again you can isolate x or y. So here I'm going to isolate y. So we did x plus y equals 50, and I'll make y equal to negative x plus 50. Remember, we're going to substitute that into our second equation. So it's 2x plus 5 times negative x plus 50, because that's where our y was, right here, equals 145. And now we're going to solve for that equation. So I could distribute. So negative x times 5 is negative 5x. 5 times 50 is 250. Combine like terms, we get negative 3x plus 250 equals 145. Subtract 250 from both sides. So we get negative 105. And divide both sides by negative 3, and we get 35. So if we have 35 of those 2-point questions, we could plug that in to see how many 5-point questions we have. So that's going to be negative 35 plus 50, or you could say 15. So to double check that, I'm going to plug that into the equations. So I knew that the 2x plus the 4y equaled 145. So let me just double check. We have x is 35, y is 5, so we'll put 2 times 35 plus 4 times 15. Does that equal 145? That's 70 and 60. Oh, sorry, that was 5, that's why. This would be 5y, not 4y. So that's going to be plus 75, which equals 145. So the answer, I want to make sure we write this down, because it's not saying what's x or y, right? We have to make sure that we say that there's 35 2-point questions, and there's 15 5-point questions. All right, so looking at that up here, I actually didn't do that up here either, so I need to make sure I put that up there. So this was 700 children and 1,500 adults. We use the system of equations to solve it, but I need to make sure I answer with a word answer. Okay, for the last one, we're going to talk about animals in a barn. We have chickens and pigs, and 13 animals in total. Now they say something funny, there's 40 legs in all. So remember, chickens have 2 legs, where the pigs would have 4. Okay, so we're going to have 2 equations, one with the number of animals and one with the number of legs. So let's identify our variables first. So we could say C is for chickens, number of chickens. And we could use P for number of pigs. You could use X and Y as well. Okay, so the total number, we have C number of chickens and P number of pigs, and we have a total of 13 animals. Now let's talk about the legs. All right, so we have 2 legs per chicken, right? So 2C, 4 legs on every pig, for a total of 40 legs. Now for this one, again, you can isolate whichever variable you want. right? So we'll have, I'll say so C plus P equals 13. And I'll make C equal to negative P plus 13 by subtracting P from both sides. Now we're going to substitute that into the second equation. So 2 times negative P plus 13 plus 4P equals 40. From here, we're going to solve for the number of pigs. So we're going to have to make sure we distribute. So that's negative 2P plus 26 plus 4P equals 40. Combine the number of pigs. So we have 2P plus 26. And when we subtract 26 from both sides, we get 2P equals 14. And divide by 2, so we must have 7 pigs. Now we're going to plug that into our equation to see how many number of chickens. And you could probably do it really quickly because we knew that there are 13 animals in there, right? So negative P plus 13, plug in 7, and you should know that there's going to be 6 chickens. And how can we check? We can check by plugging it into the equation. So 2 times P, which was our 7. Oh, sorry, that was 2C first. So 2 times C, which is 6. And then 4 times 7. Does that equal 40? So 12 plus 28 does indeed equal 40. So we must have 6 chickens and 7 pigs in the barn.